Okay, do me a favor real quick. Just blank. Go ahead. Now, how long did that actually take? It's literally just a fraction of a moment, right? Something so incredibly fast, we barely even register that it just happened. But what if I told you that long before digital stopwatches, long before mechanical gears, or even the concept of the modern hour, ancient scholars were already calculating and naming that exact micro moment? Today, we are going on a really fascinating journey. We're going to see how humanity went from measuring these fleeting little moments by just observing nature, all the way to wielding the absolute mind-boggling precision of modern atomic clocks. Welcome to The Explainer, everyone. We are exploring a truly incredible timeline today, tracking the evolution of precision itself through the history of Indian timekeeping. We're going to witness this massive, sweeping shift from ancient societies who literally just watch shadows on the dirt, all the way up to the intense, complex standardization that keeps our modern, interconnected world ticking today. It's a story packed with math, astronomy, shifting empires, and just relentless human ingenuity. All right, let's jump right into part one, ancient nature and sacred texts. So picture this, you are in ancient India, and there are absolutely no physical clocks anywhere. None, zero. So how do you actually manage a complex society without a clock? Well, you measure time by strictly observing the world around you. People relied entirely on the fundamental, undeniable rhythms of the earth. We're talking the exact moment of sunrise, the sunset, and tracking the changing lengths of shadows cast on the ground throughout the day. And look, this wasn't just casual guesswork. The mathematical groundwork for tracking time this way was detailed heavily in sacred texts, like the Vedas and the Surya Siddhanta. They essentially turned the entire natural environment into one giant, living, breathing clock. It's super cool to see how they broke this down, going from the macro to the absolute micro. They split the day into 30 units called muhurtas, with each one being roughly equivalent to 48 of our modern minutes. Half of a muhurta was a gadi, clocking in at about 24 minutes. But they went way, way smaller than that. The numesha was defined literally as the blink of an eye. Think about that for a second. This proves our ancestors valued highly precise, incredibly brief units of time way before they had any sort of digital instruments to measure them. They were conceptualizing time down to the millisecond, using nothing but sharp observation and some really heavy mathematics. Which brings us to our next era, Section 2, Shadows, Water, and Stars. So here's the obvious problem. What happens when the sun goes down? Or if it's just a really cloudy day and you have no shadows to measure? Enter the Gati Yantra. This was an ancient water clock, and it measured time not by the sun, but by the continuous, super predictable flow of water. Just imagine a little metal bowl with a highly calibrated tiny hole drilled in the bottom, floating in a larger basin of water. It slowly fills up and eventually sinks at a completely predictable rate. And every single time it sinks, boom, a specific unit of time has passed. This ingenious little device was absolutely vital. It was the core technology that managed daily activities and ensured the pinpoint timing of elaborate temple rituals all across ancient India. But these early scientists weren't just looking down at bowls of water, they were looking up. Indian scholars were incredibly advanced in astronomy, taking a massive intellectual leap. The legendary scholar Aryabhata mathematically calculated the exact length of a day and tracked complex planetary movements. And again, no modern telescopes, definitely no pocket calculators. They figured out the complex mechanics of the solar system using raw geometry and brilliant observation. Because of scholars like Aryabhata, timekeeping became inextricably linked with the majestic movement of the cosmos. Time wasn't just some local earthly thing anymore. It was a universal cosmic rule. Moving on to our third stop, mechanical clocks and new rulers. So we hit the medieval era, and things shift gears literally. This is a massive technological and cultural intersection. Mechanical clocks finally begin to appear in India. But it wasn't just the machinery that changed. The whole conceptual framework of the day got a complete overhaul. The arrival of Islamic rulers introduced entirely new systems of timekeeping to the subcontinent. The biggest takeaway here is that time shifted definitively toward an hour-based structure. We're stepping away from the 48-minute muhurtas and stepping directly into the framework of time that looks very, very familiar to what you and I use today. Now, let's look at a huge turning point. Section 4, the birth of standard time. For the longest time, time itself was super local. Every specific town or region basically had its own unique time based entirely on their local observation of when the sun hit high noon. But with the British period came a really hard push for a uniform time system. Why the sudden need to change? Well, you simply cannot coordinate a massive, countrywide railway network if every single station's clock reads a different time. Imagine the absolute chaos of trying to catch a cross-country train when the town you leave from and the town you arrive in are running on completely different sundials. They desperately needed a system standardized across the entire network. And that whole mess brings us to a really monumental year, 1906. This year marks the official adoption of Indian Standard Time, or IST for short. This was the massive turning point where the countless localized sun-based clocks were finally synced up to one unified national standard. But how do you even pick one time for a subcontinent that massive? It's not like they just threw a dart at a map. Indian Standard Time was precisely mathematically anchored to the 82.5 degrees east longitude. By selecting a central geographic meridian like this, they established a perfect baseline. When the sun reaches its peak at this exact line of longitude, the time is set and every single clock on the railway network synchronizes to that one geographic moment. Boom. Local railway chaos eliminated. Just to ground this massive national standardization in a real physical location, that 82.5 degrees east longitude line passes right near Allahabad. It is honestly so fascinating to think that this specific geographic anchor point became the invisible thread, tying millions of ticking clocks together across thousands of miles. All right, let's bring it into the present day. Section 5, Modern India's Atomic Accuracy. Today, India is still locked into that exact same Indian Standard Time, officially recognized globally as UTC plus 530. It's kind of wild to realize that a geographic decision made way back in 1906, anchored near Allahabad, still fundamentally dictates the digital clock on the smartphone sitting in your pocket right now. But how we actually keep that time? Oh, that has evolved into something that's basically sci-fi. We are firmly in the atomic era now. Today's timekeeping relies on the absolute extreme precision of modern atomic clocks. We aren't looking at shadows, we aren't watching sinking water bowls, we aren't even using mechanical gears anymore. We are literally measuring the microwave signal that electrons and atoms emit when they change energy levels. It is an unfathomable level of precision. And our modern world, it completely depends on it. Your daily routines, global transport networks, GPS, instant internet communication. The whole shebang would entirely collapse into chaos without the invisible, flawless precision of these atomic clocks. So let's just take a step back for a second and look at this whole timeline. The trajectory of human advancement here is truly stunning. We started in the ancient era, literally just observing shadows and nature to figure out where we were in the day. By the 5th century, you've got Aryabhata doing massive mathematical planetary calculations. Then the medieval era brings us mechanical gears and the hour system. 1906 forces a uniform Indian Standard Time to connect a sprawling railway. And today, we rely on the microscopic perfection of atomic accuracy. Which kind of leaves us with one giant provocative question. If humanity went from measuring something as simple as the blink of an eye to tracking the invisible vibrations of atoms, how in the world will we measure time next? When our communication and our travel reach even further into the depths of space, what will that next leap in precision even look like? It's definitely a fascinating question to ponder. Well, thank you so much for joining me on this deep dive into the incredible evolution of timekeeping. Keep questioning, keep learning, and I'll catch you in the next explainer.